Hello all, I'm Dr. Rizvi and this is part 2 of our video on Mohr circle. In the previous lecture we have learned the assumptions and basic of Mohr circle. In this lecture we will discuss few cases on Mohr circle. So let us start with case 1. The case 1 is Mohr circle for pure uniaxial tension. When we have a condition like this, when an element is subjected to only one uniaxial tension and stress is in only one direction. For these type of problems, first of all we will plot x and y axis. We will mark the origin. This is x axis, this is y axis. The value of sigma x, we will scale it. For example, if sigma x is 100 kilonewton per meter square or any other value, let us scale it in centimeters and take 1 centimeter equals to 10 kilonewton per meter square, for example. So sigma x will be equals to 10 centimeter, as we are taking 1 centimeter equals to 10 kilonewton per meter square. So sigma x will be equals to 10 centimeter. And while coming on this scale, we will mark 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 marking will mark on x-axis because this is a direct stress or normal stress, and all the direct stresses are represented on x-axis. So we will mark these on x-axis and we will mark this point as A. We'll take the center of this circle and we'll mark it as C, and now we will draw a circle taking C as center. This is the Mohr circle for pure uniaxial tension. You will draw this with the help of compass, and you will draw the line using scales and using proper scale. In this we can find the coordinates of the center. The center coordinates are sigma x by 2 comma 0. These are the coordinates of center C. The principal stresses sigma 1 and sigma 2 we can also find out from here. The maximum extent here is sigma 1, and sigma 1 will be equals to sigma x. And since the other end of the Mohr circle is at origin, therefore sigma 2 will be equals to 0. These are the principal stresses. Principal stresses. And we have also discussed that the tau max, the maximum shear stress, is equals to the radius of the Mohr circle. So this will be equals to sigma x by 2 because it is at the middle of this O and A, and total is sigma x. So the radius is sigma x by 2, and this will be equals to the maximum shear stress. So this is case 1 that we have discussed here of Mohr circle for pure uniaxial tension. Now we will discuss case 2, and the case 2 is for Mohr circle for pure uniaxial compression. Case 2. Mohr's circle for pure uniaxial compression. That is, the element is subjected to a single compressive stress sigma x. This is the element. This is the direct compressive stress. So again we will plot y-axis, we will plot x-axis, we will mark the origin. This is x, this is y. And let us take sigma x equals to 100 kilonewton per meter square. Now we will take the scale, and in scale we take 1 centimeter equals to 10 kilonewton per meter square, and now we know that sigma x will be equals to 10 centimeter. So we will again mark 10 markings as per the scale: 1 2 3 4 5 6 7 8 9 10. We are plotting it on wrong direction, so we will mark it on negative x-axis, because this is the direct stress and the compressive direct stresses are plotted on negative x-axis. So 1 2 3 4 5 6 7 8 9 10. This will be the point A, and now we will mark the point C from here. This will be the center of the circle, and now we will draw the circle in negative direction. This will be the Mohr circle for pure uniaxial compression, and it will be in negative x direction. Here the coordinates of center are minus sigma x by 2 comma 0, and we know that the principal stresses sigma 1 and sigma 2. Sigma 1 equals to minus sigma x, and sigma 2 will be equals to 0, and the maximum shear stress tau max will be equals to the radius, and here also, since we take the magnitude, the radius will be sigma x by 2. So this is the case 2 for Mohr circle considering pure uniaxial compression. Now we will move on to case 3. Case 3. Case 3 is Mohr's circle for pure shear. That is, the element is only subjected to shear stress only. Only shear stress like this. And the shear stress is represented by tau. Since we have discussed in our assumptions that clockwise movement, counterclockwise movement produced by the shear stress, they are considered as negative, and clockwise movement of the shear stresses are considered as positive. Here we can see that this face of the element is having clockwise shear stress, and this face is having anti-clockwise shear stress. So while plotting, we will plot it on y axis, negative y and positive y. This is negative y axis, this is positive y, this is positive x, and this is negative x. For example, tau is equals to 30 kilonewton per meter square. So we'll scale it. 1 centimeter equals to 10 kilonewton per meter square. So tau will be equals to 3 centimeter. We'll plot the positive tau here. 1 2 3, and here the negative tau. 1 2 3, with this origin as center, and with this point let it be C, and let this point be D. With OC or OD as radius, we will draw a circle. This will be the Mohr's circle for pure shear. Mark this point as A and mark this point as B. Here you can see that the coordinates of the center are 0, 0, and the principal stresses are, this will be the sigma 1 and this will be sigma 2. So sigma 1 equals to positive tau and sigma 2 will be negative tau, and the maximum shear stress tau max will be equals to the radius, and radius is equals to tau, and it is equals to tau, that is 30 kilonewton per meter square as taken as example in this case. So this is case 3 for Mohr circle having pure shear. Now we will move on to case 4, that is for pure biaxial tension. Now we will draw the Mohr circle for pure biaxial tension. Case 4. Mohr circle for pure biaxial tension. In case 1 we have discussed for uniaxial tension, but we are now discussing it for biaxial tension, that is two mutually perpendicular stresses are acting on the element sigma x and sigma y. Let us consider sigma x greater than sigma y and we will scale it again. Now since both the stresses are tensile in nature, so both will be positive, and we will plot it on positive x-axis. Positive x-axis. Let this point be A and this point be B. Sigma x equals to OA, sigma y equals to OB. Since sigma x is greater than sigma y, so it will be more. Now we will mark the center of this these 2 points A and B, and with CA or CB as radius, we'll draw a circle about point C. This will be the Mohr circle for pure biaxial tension. Here this value is sigma y and this value is sigma x. You must use a scale and compass for drawing proper Mohr circle. Here the coordinate of the center C will be this point. Coordinate of the center will be sigma x minus sigma y upon 2 comma 0. Since it is lying on y x-axis, so y is 0. How it is sigma x minus sigma y upon 2? Since this is the radius and we can find the radius from here, the total we will mark as OA minus OB upon 2. So OA is sigma x minus sigma y upon 2. This will be the coordinates of the center of this Mohr circle. We can also say find the principal stresses. The principal stresses here will be sigma 1 and sigma 2. Sigma 1 will be equals to sigma x and sigma 2 will be equals to sigma y. These are the extreme limits of the Mohr circle. Here this is the extreme limit of Mohr circle, maximum limit. This is principal stress sigma 1, and at point B it is sigma 2 equals to sigma y. and the maximum shear stress tau max will be equals to the radius of this Mohr circle. So in this video we have discussed four cases of Mohr circle, and the four cases are: case 1 we have discussed. Case 1 was Mohr circle for Mohr circle for uniaxial tension. Case 2 was for Mohr circle for pure uniaxial compression. Case 3 was of Mohr circle for pure shear. And finally, we have discussed case 4, that is Mohr circle for pure biaxial tension. In the later video, in the next part, we will discuss few more cases on Mohr circle. Subscribe our channel on YouTube. Thank you.